Okay? So the irrational is a level 0 player, and the rationals, the R's, are all perfectly unboundedly rational and have rational expectations. Okay? Now we know that the fully rational equilibrium excuse me, is for everyone to play 0. Right? If they were all R's, they'd all play 0. What does iterative deletion of dominated strategies predict for the case where there's just one irrational level 0 player? Okay, one bozo. In round 1, okay, if all of the 9 R's were to play their equilibrium, perfectly rational equilibrium strategy of 0, and IR played 50, then Y bar would be the weighted average of those things, which is 5. Yeah, 0.9 times 0, so you've got 9/10 of the players are playing 0, and 1/10 of the players are playing 50, so the weighted average of their guesses is 5. Okay, so that would be Y bar, and so the R's would want to guess 0.95, which is P, times that 5, which is 4.75, which isn't what they guessed, right? So that's not an equilibrium. So the next round of iterative deletion, if you want to think of it that way, R's know this, okay? So they'll guess 4.75, the weighted average will be 9.275, which means that R's will want to guess 95% of that, which is 8.811, yada, 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 right? And if you keep doing this for n rounds, each round will spit out a number xn, which is basically 0.95 times the weighted average of 50 and the x from the round before. And then if you let n go to infinity, what happens is that as n goes to infinity, this number has to be equal to that number, right? They will converge. And so you get a number based on plugging in xn, basically xn will approach xn minus 1, so in effect it'll be the same. So you get an equilibrium x star that solves this equation with these two numbers being set equal, right? And if you solve that, you get 32.4, which is, does everybody know that symbol? It means way bigger than. Yeah. Why is the fully rational equilibrium 0? Because that's because any number above 0 is not. So we went over this when we introduced the beauty contest with p equals 2/3. The rational equilibrium, right? Nobody would go above 66 and 2/3. Knowing that, your best guess is to go to take the average of that and go 2/3. And so that gives you a new rate. Nobody would go above 44.4. And so by doing that an infinite number of times, what you get down to is that the only thing that's not dominated by some other strategy is 0. Yeah, that's what's happening here. No, he thinks that the irrationals get guessing 50, which means if he and all the other rationals are guessing 0, then the average will be 5, so he wants to go 95% of that. No, level 0 is just guessing randomly. That's the definition of level 0. That's just the definition of level 0. Guessing randomly. And we know there are people out there who do that. I'm a level 1. Okay? So even though there's only one irrational, even though there's only one quote-unquote, where am I? Where did I get myself? I went to the end of the thing. I went to end. Don't press the end button. That's a bad idea. So even though only one player is irrational, the equilibrium play for the fully rational players is way above the fully rational equilibrium. Now, is this model a reasonable approximation of any actual market we believe in? I don't know. I haven't thought that through. But it's simply to say that in general, it is not a reasonable assumption to say that that putting one irrational player in with a bunch of rational players in the game will drive the equilibrium to the rational equilibrium. It's not always the case, and this is just an existence proof. Tiago. We are assuming that the irrational player is exactly irrational. Yeah.
So this means that all the rational players are better off in this case, and there's a irrational player because they're all guessing another of 0, and the payoff is 1.5.
Yeah, so they basically the prize should get split 9 ways between the rationals, and the irrational will get nothing. And then Tiago's point is, if you did it again, you'd want to believe that the irrational player would do a little bit better eventually. And maybe you would find that. I'm sure that I don't know the literature on repeated beauty contests, but one would hope that this would begin to converge to people being a little bit smarter. Even if all they did was to guess what the other people who won last time guessed. When I was racing sailboats, one of the most common suggestions was pay attention to the boat ahead of you, right? Because they're obviously doing something you're not. Yeah.
The rational player includes some like what he includes the average of the other people.
Sorry?
Because here there are 10 people, right? 9 rational players and 1 irrational.
Yeah.
So here you said if the answer, he makes the average between 9 rational players and 1 irrational.
Yeah.
Yeah.
This is just a mathematical device by which, this is just iterative deletion of dominated strategies. Neither of these, this is, by the way, iterative deletion of dominated strategies is not a model of bounded rationality. It is not a model of how people actually make decisions. It's an equilibrium concept that allows us, as economists, to come up with something that's equilibrium. There's no he involved here. There's no human being involved in any of these steps. These are just steps of math. This is not a model of how people make decisions. This is a model of how economists drive an equilibrium. The thing about game theory, about rational game theory, that is and should be most dissatisfying is that the solution concepts, other than dominance and iterative deletion of dominated strategies, typically, national equilibrium doesn't involve any idea of how people actually do their work. This, even here with the iterative deletion of dominated strategies, it's not intended to describe how people actually think. It is simply to say, there's no reason why you would play a strategy that's dominated. So your opponents, knowing that, will know that you won't, and also you shouldn't. And if we do enough rounds of that, we'll come to some kind of equilibrium. Now, there are situations in which that starts to look like how people actually play. This is not one of them. A rational equilibrium concept like iterative deletion of dominated strategies is not intended to tell us anything about how people actually cognitively think through their answers. So it's not required to satisfy that condition. It can look like nobody would ever do that and still be a perfectly valid equilibrium concept within the structure of standard neoclassical game theory. Okay, so here's an existence proof that there are situations in which irrationality can still have a considerable impact on equilibrium outcomes for rational players. It doesn't necessarily tell us what happens in real markets, but it tells us that as a generalizable assumption, dumping a small number of irrationals amongst a large number of irrationals among a large number of rationals doesn't eliminate the impact of irrationality. Okay, so we could then ask, under what kinds of conditions would irrationals have a big effect? When there are congestion effects, right? So for example, a population of drivers chooses between two identical routes, right? Okay, the more people take a route, the worse it gets. What will rational drivers do if irrational drivers randomly take road 1? Well, they'll just take road 2 and things will balance out. And so irrational players will not have much of an impact. If there are synergistic effects of irrationality, so the dumb example I'm giving you is two identical parties, and the more people go to a party, the better it gets, right? As opposed to the road, where the more people take the road, the worse it gets. I mean, unless you're having a party on the road. What will rational students do if irrational randomly go to party 1? Well, they'll all go to party 1. Okay? And so here, rational players have a sort of synergistic impact. And then you could take those observations and start to think about economic situations in which irrationality might have a larger or smaller impact or a more lasting impact. The other question we might want to ask about whether or not irrationality can survive amongst rationality is not just this kind of comes back to Tiago's comment about why wouldn't the irrational player in the beauty contest figure out, hey, I'm losing. What am I doing wrong? Maybe it's because I'm irrational. So that's a case where irrationality is manifestly hurting the irrational player. So we might want to ask, are there situations in which that's not the case, right? So an obvious but incorrect assumption that people often make is that since irrationals are, at least sometimes, failing to maximize their own utility function, stands to reason that if you're not maximizing your own utility function, you're going to get hurt, right? But it actually turns out it may stand to reason, but it doesn't actually withstand reason. It's not actually true. So here's just one example of contradiction. And again, this is just by way of an existence proof, okay? In general, the welfare consequences of irrationality are very, very complicated. So for example, we saw a couple of months ago how if you have two people who are identically irrational with respect to their beta-delta preferences, right, same beta, that the one who's sophisticated, that's to say has rational expectations, doesn't necessarily always do better than the one who's naive, that's to say has irrational expectations. So a higher degree of rationality doesn't always mean that you do better. So here's just a somewhat silly example to just sort of show that there are cases in which particular kinds of irrationality might not only survive but actually thrive. Okay, so imagine a two-person second price auction for an iPod. Raise your hand if you've never made a bid on eBay. Okay, so everybody else knows how second price auction works. And for those of you who haven't, hopefully it's not too hard to understand. Basically, the players simultaneously submit bids without knowing anything about the other player. The higher bid wins the object, but pays the second highest bid. Right? This is called a second price auction or a victory auction. And then the rule in this game is going to be that if there's only one bid, well, it's really the same rule. You win it, and then you play the second highest bid, which is 0. Okay? It turns out that this is incentive compatible. I'm not going to prove that now. It is mathematically identical, as it turns out, to the Becker group Marshak mechanism. And it's incentive compatible to simply bid your true valuation, whatever that happens to be. Because otherwise, there's a chance that if you bid above your true valuation, there's a chance that you'll be outbid and get something that is worth as much as it was worth to the other player, which is more than it's worth to you, right? So, okay, so it's a fact that the dominant strategy is to bid your true valuation. But we might want to ask, what if bidder 1 is irrational? And a particular way that we're going to make bidder 1 irrational is that she's going to bid 200 regardless of her true valuation. Sorry, I skipped the range. They both have a range of valuation that's somewhere between 0 and 200. And presumably that's because you can just go get an iPod for $200 on the Buy It Now button, right? So what happens here? Right? It sounds like that's bad. If you're always going to bid 200, the other player might come in under you. So for example, if your true valuation is 50, you bid 200, the other player happens to bid 100, you win it, pay 100 for something that was only worth 50, you're a moron. That's got to hurt. That's got to be bad for you. But suppose that bidder 2, who's rational, knows, right? So they not only have rational, they're not only not boundedly rational in how they make choices, but they also have rational expectations. They know that bidder 1 is irrational. In addition, suppose that the auction has some small participation fee. Anything above 0 will get us the result that we'll see, which is basically rational bidder 2 will not participate in the auction at all, right? Because they know that there's absolutely no possibility of them getting any positive consumer surplus. Right? Even if their true valuation was 200, bidding 200 would either they randomly be, the other player's going to bid 200, so one there'd be some coin flip perhaps, and they wouldn't get it, or they'd get it, get 0 consumer surplus and pay a participation fee, right? So rational player 2 will simply stay out of the auction, okay? Which means sort of what's going on, right, is that the irrationality is scaring away opponents. Many years ago, I was in a windsurfing accident, and I broke my 4 front teeth in half. It was among the more painful experiences I've had. And in the process of getting the 4 lovely store-bought crowns that you now see, I spent a few weeks with my teeth cut in half. And I looked like a freak. And I'll tell you something. Moving through the world looking like a scary freak is totally different than walking through the world with a nice store-bought smile. People got out of my way. That guy's crazy. He's little, but he's crazy. It's very funny. Okay. So let's think in broad terms for a moment. A common classical argument, meaning sort of a standard economist argument, right? Irrationality can be ignored in economic models of real-world markets because irrational players will do badly relative to rational players and be eliminated from the market, or if they're not eliminated, they'll have no effect, right? And you'll be surprised by how convinced people can be of this conclusion without actually testing it. Right? So we just subjected it to a couple of simple tests, and we found that it's wrong. In at least a couple of simple ways, there are many other ways, some of which we have already seen, in which this assumption is wrong, this argument rather, right? So one possibility is that rational players actually do quite well. Another possibility is that even if there's only a few of them, they can have a big effect. Real-world example. Noise traders. This is a paper by DeLong, Schleifer, Summers, and Waldman. Now, normally I would just put DeLong at all, but I didn't want to because I really want you to see that we're actually panning out from super trivial little lab games to the real world. So this is J. Bradford DeLong, who is should be famous to you. He's a big-time blogger and served under Larry Summers in the Clinton Treasury, I believe. Andre Schleifer, who you may not know, he's a Harvard economist, one of his many claims to fame. He was the principal advisor to the Russian government when they went from communism to a market economy. Larry Summers, around here might be, and I would consider this unfortunate, best known for being a sexist pig in his stint as the president of Harvard. But in addition to that, served as he wasn't the Secretary of the Treasury, was he? He was Clinton's Treasury Secretary, and he's currently the director of the White House National Economic Council. And Robert Waldman, who is a famous European economist. And their argument is basically this: in the stock market during a big bubble, rational traders may not be able to arbitrage the irrational investments of what they call noise traders, right? So small-time independent investors, maybe not even necessarily that small time, who get caught up in what Keynes referred to as animal spirits, right? It's an exciting day in the trading pit, and I'm doing silly things. I'm inflating. I'm riding a wave. I'm thinking, gosh, this winners have to keep winning. It has to be true. I'm a believer in the law of small numbers. I'm riding this wave. And what rational economists want to say is this can't survive because the rational traders will arbitrage the mispricing in the bubble and bring the prices back down to where they should be. And what these guys showed is that when there are limits to arbitrage, it takes work and it takes guts. So you have to wait out the bubble in order to successfully arbitrage it, and that can take years in some cases. Right? The dot-com bubble rolled for a few years, and it was just manifestly not possible for rational traders to fully arbitrage the irrationality in the market. Okay. and it turns out that this can survive, there's no particular a priori reason to think that rational arbitrageurs will eliminate the effect of irrational noise traders if there are limits on their economic ability, their financial ability to arbitrage the market, to arbitrage the irrationality. Okay, now, that's all I want to say about that. But let me just say a couple of things to sum up the semester. Let's go back to our buddy Milt Friedman. We said a bunch of things I won't reiterate. And the summary of them all was that basically our models, our rational models, may be loopy and may not survive the investigation of a psychologist, but we don't actually care about that provided that they make sufficiently accurate predictions. And I hope I have convinced you that I agree with Milton Friedman completely on this point. And the only way in which he's wrong is that the assumptions of rationality do not, in fact, make sufficiently accurate predictions. In 1948, when he said this, he was simply wrong about the degree of error in prediction that rationality assumptions lead to. What about Dan Ariely, who said a lot of things that I won't reiterate about how devastating the effect of irrationality can be on the effectiveness of markets, and asked the question, where does this leave us? And of course, his answer to the question was that if markets, because of irrationality, will not actually generate Higgs-Calder efficiency and send us all home as happy as we can possibly be, then we must resort to government intervention. And I hope that I've convinced you that I agree with Dan Ariely that violations of the assumption of rationality that survive in market circumstances and therefore are violations of the assumptions of the first fundamental welfare theorem do provide necessary grounds. They give us reason to think that there might be a government intervention that could make people better off, but not sufficient grounds for government intervention, and we should not rush willy-nilly from evidence of irrationality straight to government intervention, because it's very, very hard to get government intervention right without potentially causing more harm than good. Those are, for me, the take-home lessons of the entire field of behavioral economics, and I hope that they will be among the things you remember from this class. Thank you for being a wonderful class. I want to say thanks to a few people at your GSIs. Could you maybe please stand up? And where's Mia? Mia Lee, who's been your ASUC note-taker all semester. And thanks to all of you as well. It's been a great pleasure teaching you.